Everything wrong with this bead roller. I just disassembled this bead roller, cleaned all the parts with the parts washer and started to inspect everything to make a detailed plan for each part of this restoration. First things first, this bead roller was produced in Rupperswil in Switzerland around 1917 by a company called Ferrum. They usually make can seamer machines and are still in business today. I contacted them, but unfortunately they don't have any information anymore from this bead roller. The other aluminium tag was added later by the previous owner of this machine, so it is not an original piece and I won't put it back on it. Unfortunately, I wasn't able to find out what this company was making. I couldn't find any information online. After cleaning, I put the bead roller back together to inspect its function and all the fitments of the moving parts. I can definitely say that it is still in working order, although the machine has definitely seen some better days. Almost all the guided sections of the shafts and moving parts have a lot of play due to years of use. The machine has been repaired and modified a few times and a lot of original parts have been replaced. Let's just go over every single point I figured out. As just mentioned, the aluminium tag was added later, so I won't put this back on it. The handwheel is definitely not an original piece of the speed roller. It kind of fits the design of it, but it was definitely added later at some point. You can just see that because the shaft is longer than the bore of the handwheel. It's also made from cast aluminium. All the other parts are cast iron. And also almost all the bead rollers have cranks, not handwheels. So I'm definitely going to replace this one with a crank. You can just tell by looking at it that this dead stop is definitely not original. The plate is made from stainless steel attached with socket Allen countersunk screws. These two rods might be original as they look pretty old, but also these two small steel plates look like they have been added later. While doing some research, I found most bead rollers have the front plate as thick as these small plates, also having it directly mounted to the two guiding rods. This design with the small plates and the relatively thin stainless steel faceplate makes the whole dead stop a bit fragile and sometimes difficult to adjust. So I'm definitely going to change that with a more rigid solution, as well as a more looking like 100 years old design to fit this antique bead roller. Then there's also these two clamping screws, or how you want to call them, for the dead stop. These seem to be self-made with a piece of bent threaded shaft. They're also made from stainless steel, and you can tell by the look of them that they are definitely not original. So I'm also going to replace them with a more appropriate 100 years old looking design. Maybe something like a T-shaped screw, a knurled screw, or something like a wing screw. I don't know just yet. This depth adjuster crank also does not look original. It's just a band rod welded onto a hex screw head. I'll also make something new here. Maybe a little crank would be nice, or a T-shaped screw. This was also far from the not original parts that I'm going to change to recreate a more antique look. Now let's take a look at the functional parts and all the worn out fitments. But first of all, I'm going to show you the function of the speed roller. You can roll over a 90-degree edge, for example, or just make some beads into sheet metal. It is definitely a must-have machine for a car body workshop. You'll always have a set of dies installed in front of the two shafts. They're always a pair and you choose them whatever kind of job you want to make. With these two dies, I can make a round bead into the metal. To function correctly, the dies need to be aligned with each other. Means the round profile of the upper die needs to match the profile of the lower one. To achieve that, you can adjust the position of the lower die with the lever. By moving it, the shaft is moving back and forth. Once you got your dies aligned, you can lock the lever position by tightening the screw in the back. Now you need to adjust the distance between the dies with this crank up here. You just set it to the correct distance regarding the thickness of your sheet you want to work on. Now everything is ready to start rolling a bead. Just guide the sheet metal into the dies and start turning the hand wheel. I can move the sheet around freely with one hand and make curves and such. or I can just set the dead stop to a certain distance to run a straight and consistent bead. Also, the throat opening here defines how big your sheet can maximally be, or how much distance you can roll a bead to the edge of the sheet. So this machine still works, as you can see, but all the fitments have a lot of play, the dies are not running through, and overall it feels very sloppy. So it really needs a restoration. Let's go over everything I need to fix here to have a perfectly working machine in the end. So, first of all, there are a bunch of small washers installed on the lower shaft. These eliminate axial play from the shaft. This play is coming from the section of the shaft which is definitely too long for the adjustment lever. I could turn his shoulder back on the shaft, but because the gear is attached with the tapered pin, I would still need washers to adjust the distance. As well, I think this is not the original 100 years old shaft. Also just by the look of the key slot in the end. Usually machinists back then used slitting saws instead of tiny end mills to make such keyways. You can also see some clamping marks from a 3-jaw jog right here. The shaft also has a bunch of play in the bushing in the front here. So I'm going to make a new shaft from scratch. Taking a closer look to the adjuster lever. It has a lot of play inside the body. I can't really make a sleeve onto this section. Also, welding up material is not really an option because the area is too big and I'd risk the part to warp. And because this part looks like an original one, I'm going to restore it. I'm going to turn this outer diameter clean and round on a lathe. To achieve a nice fit, I'm going to widen up the hole in the body and install a sleeve. I also need to replace this brass sleeve here since it's not even round anymore. It also seems that it has been pushed back because right now the shaft is touching the body on the chamfer. It's rubbing against that and you can already see how chewed up the shaft looks on the chamfer. This screw is guiding the adjuster lever in this spiral slot to move back and forth. When you fully tighten the screw, it will actually touch the shaft and lock it. And this is not what it should do. You can actually see the marks of the screws on the shaft right here. To avoid that, the screw needs to be loose all the time or you'd need a lock nut. But since the screw doesn't look original anyway, I'm going to make a more elegant solution where you can fully tighten the screw against the body and still be able to move all the parts. A similar problem is also on the opposite side of the body. This screw locks the position of the adjuster lever. It just pushes onto the adjuster lever directly, steel on steel. You can also see quite some marks of that. So I'm also going to remake that with a more elegant solution. I'm thinking about a brass pin between the screw and the lever, and also a nicer design for the screw head. The upper shaft also had these 3 washers between the gear and this piece. I can't see any function of them, except for reducing the axial movement. And looking at it closely, they seem to be on the wrong side of the shaft. Because right now the gears match when the lever is on one end of its position. On the other end, the gears just engage on their edge. Theoretically, it should be even. Means the gears should match in the middle position of the lever. This would be the case if the axial play of the shaft is eliminated on the left side. The shaft also has quite a lot of play in this piece. As this piece is too thin here already, I can't install a bushing. Therefore, the only solution will be to make a new shaft as well. This piece, which holds the upper shaft, pivots around these 2 holes in the sides. They look a bit chewed up, because the tip of the screws don't really fit in there. But not a big deal. I'm just going to clean these holes up and restore the rest of this part, as it looks to be in working condition otherwise. Just talking about these 2 screws, there's the same issue here, like on the lower one from the adjuster lever. When tightened completely, it actually clamps the part, which it shouldn't. So I'm also going to replace them with new ones. When fully tightened, don't lock anything, and also making some nice appropriate matching screw heads for them. The gears themselves are looking a bit rough, but they should be restorable. I'll try to close the tapered holes so I can later drill and ream new ones to get a nice connection with the new shafts. So right now you got a pretty good overview from this project. It kind of brings the ship of Theseus problem to light. There will be barely anything left from the original when I'm done, because there's already barely anything left from the original. But since I want to keep this bead roller as a tool in my workshop, like the Beverly shear or the arbor press for example, I want it to be in perfectly functional and working condition, yet still with an antique look. Thanks for watching. Wait, don't turn off the video just yet, I got some more information. So I just started working on the body and found something very interesting. I widened up this hole with my DIY boring head and removed this press-fitted brass sleeve. Then I took a closer look at all the frets and had to realize that most of them are imperial size frets. BSW, British Standard Whitworth to be precise. I just assumed all of them are metric because it's a Swiss product. It's indeed actually quite common for such old products to have imperial size frets. That's not the first time I've seen that. All the frets in the body are different sizes of BSW frets. But I also found some metric frets on this bead roller. The two screws holding the dead stop plate. But on these it was already obvious that they're not original. I was more surprised to find a metric fret on the screws that hold the dies. I mean, it was clear that this zinc plated screw is not 100 years old. But I really thought this big slotted screw was original. Turns out it is not. So I'm also going to replace both of them with new ones. Since both screws have M8 frets. Means also the shafts have M8 inside frets. But I kind of knew before that both shafts are not original and 100 years old. Thanks for watching.